Okay, now we finally made it to step 10, and we want to figure out the mass of the planet. So in order to do that, let's again draw a small picture of what we have. So at the moment, we know that we have our sun, label right there, and we know that the planet is going to orbit around the sun. So we have our little planet right here. Okay, this is the planet. And the planet, right, is going to orbit around the sun in a circle. So this is what we have at the moment. So let's write out the force, the gravitational force of the sun on the planet. So we know from the previous coding videos that the force of the sun on the planet, which I'm going to write as S on P, force of sun on the planet, is going to equal to gravitational constant times the mass of the sun times the mass of the planet divided by r of the planet squared. This is all the magnitude of the force because we have no vectors and we have no direction of this. So this is all just the magnitude. So now we know that we can substitute force of the sun on the planet with Newton's second law, which is F equal to ma. So if we replace this with mass of the planet times the acceleration of the planet, it's going to equal, again, g m sun m planet over r planet squared. Now we can simplify this a little bit by noticing that we have mass on the planet on both the left and the right side. So we can divide each side by the mass of the planet, divide this side by mass of the planet, so that both these quantities cancel out, and we are left with the acceleration of the planet equals g m sun over the radius of the planet squared.
And we can continue on by noting that the planet is in circular motion around the star. So what that means for uniform circular motion is that the acceleration that it experiences is actually given by the velocity of the object, so the planet, that velocity squared divided by its radius from the star. So a planet simply becomes v squared planet over r planet, which I will just say is equal to g, the mass of the star, divided by the radius of the planet squared. And in the next step, we want to use the fact that the velocity of the planet is equal to this quantity related to the period. It's actually equal to 2 pi times radius of the planet divided by the period. So I'll actually write here as a separate step that v of the planet is equal to 2 pi times r of the planet divided by the period. So why does this equation make sense? Velocity is just distance divided by time, right? The distance that you're traveling in circular motion is the circumference of a circle, which is just 2 pi times the radius of the circle. So that's why the numerator has a 2 pi r. And then the time it takes to go this entire trip is the period, which we symbolize with t. So velocity here is just distance over time, which is something you're very familiar with. Now I can plug in this Vp into this equation, which I will get, I'll pull out the 1 over Rp in front, so that way I can put everything else in parentheses here. 2 pi Rp divided by t. Remember, all of this is squared, and that's equal to g m of r star over Rp squared. All right, and the next step, I want to expand this so we can actually simplify a bit further. So it's a very straightforward expansion. We have 1 over Rp times 4 pi squared Rp squared over t squared again, the right-hand side is unchanged here. So over here we see we have an RP in the denominator and an RP squared in the numerator. So one of these will cancel, one of those. Now to save myself a few steps and to get through the calculation a little bit quicker, we will multiply in one step RP squared on both sides. So I'll say times an RP squared in the numerator times an RP squared here. Okay, so I'll multiply r squared on both sides. And notice on the right-hand side here, this RP squared in the numerator cancels with this RP squared in the denominator. And then on the left-hand side of the equation, this RP squared gets multiplied by the leftover RP up here. So putting that together, we have RP cubed times 4 pi squared over t squared is equal to g mass of the sun. And in the next step, I can simplify for RP cubed by dividing out by this quantity here, the 4 pi squared t squared. And you might remember that when you're dealing with fractions, division is the same thing as multiplying by its inverse. So I'm going to move over here for a little bit more space. Just draw my arrow. And going from here to the next line, I'm going to multiply each side by t squared over 4 pi squared. It is t squared divided by 4 pi squared times the RP cubed, that's still down there, times the inverse of this thing, 4 pi squared over t squared, is now equal to GMS. So notice, oh yes, I did say I had to do both sides. So before I cancel, actually, I need to make sure that I put times t squared over 4 pi squared. So this 4 pi squared cancels with this one, and this t squared cancels with that one. And now we have RP cubed equals GMS t squared divided by 4 pi squared. And the last step now is just take the cube root of both sides to simplify and find RP. So RP, and I will demonstrate the root by just using an exponent here. And the cube root is the same as 2 to the 1 divided by 3 power. And you can plug in all your values, and you find that RP is equal to 93.6.
And remember that we chose the value of the period t to be 18. So you remember what number goes in for t. So remember that the period for the planet going around the sun we found it was 18. The mass of the sun is equal to 1. G is equal to 10 to the 5. So you have these numbers here to plug those in.
Yeah.
All right, so now that we figured out what the radius of the planet is, this radius, we can find out the velocity that it is at which it's going around the sun. And to do that, we use the equation that Jamor wrote earlier, which is that the velocity of the planet is equal to 2 pi times the radius of the planet divided by our period. So if we let's just write this out again. Sure. So remember, velocity of planets, 2 pi rp divided by our period. So now we need to take momentarily take a step back and think about what we want to find. So we want to find the mass of the planet. So at little mp, this is what we want to find. And so far, we are given a radius and we can figure out a velocity. But what can we do with that? How can we figure out the mass of the planet? Well, with that, we can think about going back to the previous step where we used conservation of momentum. And to remind you all, that was the mass of the sun times the velocity of the sun equals what we figured out that this, in order for the sun not to be moving around, it was equal to negative mass of the planet times velocity of the planet. So since I mentioned up here that we're working with magnitudes, we don't want this negative sign in here because that's giving us a direction. So a way to get rid of that negative is by taking the absolute value of these quantities. That will get rid of the negative and the direction and just give us the magnitude of everything. So we can end up writing this as the mass of the sun times the velocity of the sun equals the mass of the planet times the velocity of the planet. Now, like I said, our goal was to figure out what the mass of the planet is. What we need to do is solve for the mass of the planet. So we can do that by dividing the right side. If we divide this by the velocity of the planet, we also divide the left side by the velocity of the planet. This will cancel out the velocity of the planet on the right side and leave us with the mass of the planet. So we can write it as mass of the planet equals mass of the sun times velocity of the sun divided by velocity of the planet. So now we have an equation for the mass of the planet. And we see that it depends on the mass of the sun, which we know is 1, the velocity of the sun, which we don't have written down, but we will write it down right now. So velocity of the sun, we figured out back a few steps ago that it was 5.77. And remember that I'm not putting in that negative because I'm just using the magnitudes of these values, not the direction. So now we have the mass of the sun, the velocity of the sun, and we need to solve for the velocity of the planet. And to solve for the velocity of the planet, we can use this equation right here. So solving it, we know that the velocity of the planet is going to equal 2 pi times the radius of the planet, which we found was 93.6. So 93.6. And divided by the period, which I mentioned earlier was 18. So now if we put this into our calculator, we find that the velocity of the planet is actually 32.7. And now we can place this value into the velocity of the planet. And just so we have all our variables written down, I'm also going to write it down here. So velocity of the planet is equal to 32.7. Okay, now let's write out all the values to find the mass of the planet. So the mass of the planet is going to equal mass of the sun, which is 1, times the velocity of the sun of 5.77, divided by the velocity of the planet, which we figured out is 32.7. And if we put this into our calculator, we will see that the mass of the planet is going to equal to 0.177. Okay, so now we figured out that the mass of the planet is about 0.177, which is about 10% off of our original mass that we had in our code, which is really great, but we could get a little closer. So make sure to check out our next video, and we will show you how to get an even closer mass of the planet.